We'll find the derivative of the natural log function using the definition of derivative. A couple of notes before we start. When we have the limit of a natural log function, natural log is a continuous function for all positive numbers. So when you're taking a limit of a continuous function, you can switch the order of these two. It becomes the natural log of that limit. And another note is that I'm going to do this derivative, but I'm not going to know yet that natural logs have base e. I'll pick a base for natural logs later on in the proof. So we'll take the derivative. We know that the derivative of function is the limit as h goes to 0 of the function evaluated at x plus h minus the function evaluated at x all over h. Now, here we have a sum inside of the natural log. We can't do too much with that. But here we have a difference of two natural logs. So when we have that, we can write that as a single natural log with a quotient inside. So this will be the limit as h goes to 0 of natural log of x plus h over x. This is still over h. Now when you have this over h right here, that's like saying multiplying by 1 over h. So I'll put that down right here. 1 over h times the natural log of x plus h over x. And now we can use another log property. We can take this 1 over h in the front and put it up as the exponent for the input of the natural log. This will now be the limit as h goes to 0 of the natural log of x plus h over x to the 1 over h power. And I'm going to take a look at this right here. I'm going to do the division. I'm going to divide the x into the numerator. So this will still be the limit as h goes to 0 of the natural log. So now x over x is 1. Then we still have the plus h over x right here. This is being raised to the 1 over h power. And now what I'm going to do is I'm going to switch the order of limit and natural log. Because natural log is a continuous function, we can do that. So this becomes the natural log of the limit as h goes to 0 of 1 plus h over x to the 1 over h power. Hopefully I have the correct number of closed parentheses. I think I do. 1 over h right here. So if we look at what we have here, we have 1. 1 is just 1. H over x is h is going to 0. This is going to 0 also. So this right here is going to 1. And then 1 over h is going to infinity. So we have 1 to the infinity. That's an indeterminate form, which means we have to do more work to figure out this limit. So I'm going to make a little substitution here. I'm going to say that u equals h over x. And I'm going to rewrite this limit entirely in terms of u. So this is going to be the limit as u goes to what? Well, we know h is going to 0. So h over x is also going to 0, which means u is just going to 0 as well, of 1 plus my h over x is the u to the 1 over, well, if we know u is h over x, that means h is u times x. So this will be 1 over ux. And in fact, perhaps I'll write this 1 over ux slightly differently. I'll write it as 1 over u times 1 over x. And now I'm going to, once again, switch the order of natural log and limit, so I can use a log property here. So this will be the limit as u goes to 0 of the natural log of 1 plus u to the 1 over u to the 1 over x. Well, actually, 1 over x is still right here. And now I'm going to use the log property where we have this power right here. I'm going to bring it out to the front as the multiple for the natural log. So this will be the limit. And as a matter of fact, because this limit is in terms of u, x acts like a constant. X doesn't change, so I can bring it all the way in front of the limit. So this will be 1 over x times the limit as u goes to 0 of natural log of 1 plus u to the 1 over u. Now, if you look at this right here, 1 plus u to 1 over to the 1 over u, we still have a 1 to the infinity situation, which is still indeterminate. Now, if you like, in this particular situation, pull out a calculator, plug in some values that get really, really close to 0, and you'll find that this quantity approaches about 2.718. This number might look familiar to you, might remind you of E. So let's take a look at the definition of E. E is the limit, defined as the limit as n goes to infinity of 1 plus n, 1 plus 1 over n to the n power. I'm going to do another substitution in this limit now. I'm going to say that u equals 1 over n. I'm going to rewrite this limit in terms of u. So we know that E is equal to the limit as u goes to what? Well, u is 1 over n, and as n is going to infinity, 1 over n is going to 0. 1 plus 1 over n is my u to the n. N is just 1 over u. You do the reciprocal on both sides right here. Now, does this look familiar? This right here. This is precisely this right here, if you just switch the order of natural log and limit again. So actually, perhaps I'll do that to make it more clear. So this will be 1 over x in the front times the natural log of the limit as u goes to 0 of 1 plus u to the 1 over u. I should probably put a parentheses right here. So that means that this right here is just e. So at this time, I'm going to say that natural log, I'm going to pick my base for natural logs to be this constant e, because that means that when you take the natural log of e, they cancel out. And this right here is just equal to 1. So 1 over x times 1 is just 1 over x. And here's our derivative for natural log of x.